Okay, greetings. Happy Super Bowl Sunday. I'm going to solve a couple problems for you here. We're going to solve this problem here. Let me get this from... Okay, so I've got 5 to the 4x minus 1 equals 1 over 125 and to the 2x plus 5, okay? Let's get this base to look like a 5, okay? So 1 over 125 is really 1 over 5 to the third power, okay? That's 5 to the third power is 125, okay? You're going to have some knowledge of factoring, all right? And if I move this up top, what happens to that exponent? If it's positive and down here, the exponent's negative up here. So I'm going to rewrite this as 5 to the 4x minus 1 equals 5 to the negative third power. But remember, I'll put that in parentheses for right now. That's our 1 over 125, right? 5 to the negative third power. Then that's also raised to the 2x plus 5, okay? So remember, when we raise a power to a power, we multiply. Okay, but notice here I've got these two bases are the same, so we've got this equals this, so basically what's over here equals this. So basically these exponents have to be set equal to each other because these quantities equal each other. So 4x minus 1 equals, this exponent equals negative 3 times that 2x plus 5. Okay, that came from what? 5 to the negative 3, that's 1 over 125. This exponent, when we raise an exponent to an exponent, we multiply. So it's negative 3 times this right here. Okay? So 4x minus 1 equals negative 3 times 2x is negative 6x, and negative 3 times plus 5 is minus 15. Okay? So I don't care how we do this, but I'll add 6x to both sides, and then I get 10x. That's 10x, okay? And that's gone. I still have a minus 1 equals negative 15. Okay? All right, so I'm going to add 1 plus 1, and I get 10x. Let's go, equals negative 14. Okay? And the final step is divide both sides by 10. And x equals negative 14 over 10, or negative 7. Divide both sides by 2, negative 7/5. And that is our answer for x. Okay? All right? That's solving for x. Okay? That's what we did, was we created like bases. Okay? All right. Let's do one more problem. We're going to solve this using logarithms. Okay? Let's do a basic problem. 4 to the x power equals 98. Okay? There's no, I can't recreate, 4 does not go into 98 evenly, so we're not going to be able to create like bases. But one way we can solve for this is using one of the rules we learned in our video last Wednesday, is that when you take the log or natural log of something, doesn't matter, of let's say, anyway, 10 to the third power, remember this exponent can be moved down front, like 3 log to the 10, okay? So knowing that, that's how we're going to get this exponent down. I'll just take the natural log. Let's take log of 4x equals the natural log of 98. Okay? So now this exponent comes down in front, and now we can divide things out. X comes down in front here of the log here. Okay, so that's x log of 4 equals the natural log of 98. Okay, make sure you guys see that. I don't know how this confused me. Okay, all right. So now when I took the log of this x comes out in front, And now it's no longer an exponent, and we can get x by itself, because this is x times the log of 4 equals the natural log of 98. ln is the natural log, base e, okay? All right, remember that. So let's divide both sides by the log of 4, okay? And that would be our answer, equals x equals the log of 4 divided by the log of 98. And there would be a value if I had my calculator. Remember, final note, there is a big difference between the log of 4 divided by the log of 98 and the log of 4 over 98. That's taking the log of some value. This is taking log of 4 and then the log of 98. This is the one that applies to the rule that this is going to equal that theorem that we had, the identity of log. This is going to equal log of 4 minus log of 98. This is the rule that pertains here. Okay? All right, so be ready to work these problems. And some of them get a little more involved, but we work them in class. All right? Happy Super Bowl. All right? Look for this video. I hope everyone watches. Okay? Bye.